want to share what they think the two the two variables are.
I will.
Okay, yeah. What'd you give the two variables?
The amount of money is a function of the amount of problems you like.
Okay, so you think
Number of problems you like.
you think that the variables are amount of money and number of problems. Okay, so to be a variable, it has to be a number that can change. So in this situation, can the amount of money somebody earns change? Yes. Can the number of problems they work change? And so those could both be variables. Anybody else find a different possible variable?
Amount of problems they do is a function of as many sponsors they get.
Okay, so you're still doing number one, which is good. You said that it was the amount of money. The amount of money is a function of, so another way to say that is depends on, right? So the amount of money that they earn depends on how many problems they work. So that would be correct. The amount of money is a function of number of problems worked. I'm sorry, I have terrible handwriting. Hopefully you can read that.
Why did you do a semicolon?
I didn't?
Oh.
That's my eye. You talking about my colon? That's an eye.
That's an eye.
Yeah. That's the way all my eyes look on the iPad. I'll never use a colon. How about that? That'll be a rule. I'll never use a colon. It'll always be an eye. The amount of money is a function of the number of problems worked. So I saw some other people talking about possible variables that could be time. All right? Could the amount of time change in this problem? No, they've got a set amount of time. They can only work for 20 minutes. Take your hood off. I don't want to see your hood off. What else could change? What else did some of y'all say for variables? I heard another one. I can't think of what it is right now. The number of sponsors. And so it's true, your number of sponsors could change as you're getting sponsors. But at this point, they've already got their sponsors set. Right? There's no more sponsors going to be added. So in this situation, the only things that change are the amount of money that they get and the number of problems that they work. Is there any questions there on identifying that? I thought for the most part we did pretty good on that. Number 2, we're going to complete the following table to show how much money Jenny and, is it Gennaro? That's what I'm going to go with. The amount of money Jenny and Gennaro earn for each number of problems that they work correctly. So we said the number of problems that they work is independent, right? That's what they get a choice over. So in my chart, we always put the independent variable first. So the number of problems. And they just pick some random possibilities. What if they both got 5 correct? Or 10 correct? 15 correct? And so on. When you make these charts, you can pick whatever numbers you want to go there. That's what makes it independent. But they've already made that decision for us. So let's say that Jenny works 5 problems correctly. So how could I find how much money Jenny earns?
Times it by 2.
Yes. So in the process column, we're going to write down what we did. Our process was to do 5 problems solved. I'm going to have to zoom in because that's pretty small. 5 problems solved times 2. Why did we decide to multiply by 2?
Because she gets $2 per problem.
Because if you read back, that's what she makes for every problem. That's from her donors. So for 5 problems solved, she gets $2 for each one. So 5 times 2 is $10. you understand how to fill that out? All right, now let's look for Gennaro. How can I find how much money Gennaro is going to make for also solving 5 problems? It's going to be 5 times 3 because he's been pledged $3 per problem. And so how much money would Gennaro earn? $15. So what I want you to do, I want you to work on filling out the rest of the chart. You see how you have these 2 with dots? That means you're not going to fill those in. Okay? Those are going to be left blank. I want you to go through, try to fill out 10 through N. And then, again, you can check with your partner. Y'all can work together, whatever you want to do. And then we'll come back together and talk about the correct answer. So if you'll look up here, I've already filled the chart out where you can check your work. But again, I think for the most part, we did a pretty good job here with that. Do what?
It's pretty straightforward.
Yeah. As long as you know how to fill out the first one, right? The trick's going to be, if I gave you a chart like this, completely blank, could you fill it out? Could you figure out what to put in for the independent variable?
Yes.
It's whatever you want.
Yeah.
Right? You get to pick those.
They go by 5s.
They did, but you could go by 1s, you could go by 10s.
How about 3?
Well, why you gonna pick 3s? I guess you could. Figure out the process to find the amount of money earned. Y'all told me how to do that pretty quickly. I do want to talk about this on this last one. N. What does N represent?
Number of problems.
So that means what? For any number of problems N. So like, if they had gotten 53 problems correct, you would do 53 times 2. If it was 1,086 problems correct, you would do 1,086 times 2. So no matter what number you choose here, that's what N represents. N is any number that you pick. You're going to do N times 2. Now I do want to mention, what's another way you can say N times 2?
2 times N.
2 times N. Somebody say of? Of does mean multiply. It's hard to probably use of when one's a number and one's a variable, though. Yeah, instead of 2 of, we don't really say 2 of N. What do we say instead?
2N?
Just 2N. If I have N times 2, that's the same thing as 2N. Because what does a number right beside a variable mean? Multiply them. So N times 2 is 2N, and N times 3 is 3N. So I just wanted to bring that up because what you're going to see more prevalently. Hey Bryson, make sure you're paying attention up here or I'm going to take your watch. 2 times N is the same thing as N times 2. But you're going to see this notation a lot more frequently. And the same thing there with 3N.
Why does nobody ever do N2?
Because the standard practice is always putting the number, which we call the coefficient. Have y'all heard that word before? Fancy word. Put the coefficient in front of the variable. If they would have made the rule to put it after the variable, then that's the way it would have looked. But they just thought it looked cleaner and nicer being in front. Just a notation thing. Okay. So we talked about, if I look at number 3, I've got 2 variables. G sub 1 represents the money earned. N represents the number of problems solved. Function notation, what does function notation look like? That typically looks like f of x. And sorry I wrote that where you couldn't see it. There it is. F of x is what function notation looks like. That's for an independent variable x and a dependent variable f or y, right? Whatever it is. So here, what's my independent variable? We just talked about it earlier. If you look back at 1, the independent variable was the number of problems solved, which is represented by N. Remember we said money depends on number of problems solved. So the N goes in parentheses. because it's the independent variable. My dependent variable here is g sub 1. So the left side of my equation, instead of saying f of x, I'm going to say g sub 1 of n. All this 1, it's just helping you keep track of which function g you're talking about. It literally means the first function g. If I did g sub 2, like I'm going to do in a second, that's the second function g. All right, and I think most people, you may need a little help to get to this point, but I think most of us can get here. We understand this is independent, this is dependent, and so I make my function. Now let's say it equals. So what is this saying? This whole thing says the amount of money Jenny makes is equal to. What does the amount of money she make depend on? So I brought up with them, if she worked 50 problems, how much money did she make?
100.
So the way we could write that is g sub 1 of, what was n in that situation? N was 50. When she worked 50 problems, she made $100. So g sub 1 of 50 is equal to 100. If she had only gotten 5 correct, we could say g sub 1 of 5 equals. How are you finding the number you put on the right? Multiplying what? 2 times
N.
the number of problems she gets correct. How many problems did she get correct here? N. She gets n correct. It's the thing that can change. So how much money would she make? 2 times n. So in function notation, g sub 1 of n is equal to 2n. Here's your little hint. Whatever your independent variable is that's in parentheses is going to be used on the right side of your equation. Otherwise, where could I plug this into? Right? Like what were we literally doing up here? You were taking 50, plugging it in here and here. Because 2 times 50 was 100. You see how that works? Here we plugged in 5 for n here and here. So that means g sub 1 of 5 was equal to 2 times 5, which was 10. So no matter what n is, you can plug it in. Yes? Better? Worse? Indifference? Try 4. Try 5. So let's fill out 4, 5, and 6. I want to make sure we have enough time to do that. We've only got about 10 minutes left. 4. What would Gennaro's function look like in function notation? It would be g sub 2 of n equals 3n. So if I saw that, that's how I would read that out loud in math. That's g sub 2. All sub means it's a subscript. It's a little number. G sub 2 of n. That's how we read function notation. G sub 2 of n equals 3n. Any questions about how to read that? How to get that answer? After I showed you 3, y'all pretty much had 4 like that. Right? Wasn't a problem. You gotta start training your brain to think that way. Again, this is the biggest problem that I see in all of our math classes. Not just algebra, not just your grade, but being able to convert words to symbols and understanding what's going on. And that's why I like this curriculum. It's doing a good job of trying to make us think. 5. What does g sub 1 of 30 represent in the situation? So if I just saw G sub 1 of 30, that represents the money Jenny earned for solving 30 questions. But that's what it's talking about. I saw some people say that Jenny worked 30 problems and made $60. That's good. Right? You're going even the next step. But if I just look at G sub 1 of 30, all this is saying is Jenny worked 30 problems and she made some money. And that's what we're talking about. It's the money Jenny made for solving 30 questions. And then they want us to actually solve it, which means find the value. So what does G sub 1 of 30 equal? It equals 60. G sub 1 of 30 equals 60. That's one way you could write it. And I saw some people write it a different way. What did I plug in? What was my input? My independent variable was 30. What was my output? What did I get in the end? 60. So what's another way we could write this instead of function notation? We could write it as an ordered pair. I plugged in 30. I got out 60.
That was my first.
I'll take either one. Those both work the same. But you need to know how to do it both. Because you never know which way you're going to see it. Okay, but those mean the same thing. And then 6 says, on the coordinate plane, sketch the graph of these functions and label the axes. Let me take a new picture to do that one, because I kind of drew all over the graph. Okay, so first, let's label the axes. Let's do that first. So again, we call this axis, this is our x-axis, right, that goes this way. And remember, x is our independent variable. So in our problem here, what was our independent variable?
Number of problems.
Number of problems solved. So if I had to label the axis, that's what I would label it. The x-axis is my number of problems solved. Okay? And then the y-axis, that's our dependent variable. What was our dependent variable
The
here?
amount of money made.
The money made. So I would label that one. They used money. Can y'all see the green okay? The green one looks better on the screen up there than it does my iPad. Money earned. Boy, my handwriting. Okay.
It's good handwriting.
It's hard to use not a pen on an iPad. Yeah, I'm so sorry.
It's great handwriting.
Now let's graph them. So if we graph, what would be the big problem with using this graph? Like our first point on the table was the point 5, 10. Okay, so 5 would go here and 10 would go here. I could get a lot of these in-between points, right? I call them crosshairs. So you'll hear me use that terminology a lot. But like the crosshairs would be where one of these vertical lines meets a horizontal line. It's like right here is a crosshair and here is a crosshair. It's a lot easier to graph these points if we make them be on crosshairs. So let's just do that. We can do it without the points that were given to us. For Jenny, if she worked 10 problems,
That's how I did it first.
how much money did she make?
20.
20. So I should have the point 10, 20 for Jenny. Okay, then what about if I went over to 20? If she worked 20 problems? I put that in the wrong place, didn't I?
Yeah, I was
Y'all didn't even scream at me. 10.
I did it wrong.
Thanks. Okay, here's 10, 20.
20 is 40.
If she worked 20 problems, she would have earned 40. If she worked 30 problems, she would be at 60, 40, 80, 50, 100, 60, 120, 70. I'm going a little quick. Do we understand where I'm getting these from? Do I need to explain? 90, 180, 100, and 200. So there would be Jenny's points.
Get it like graph from the chart.
No, as long as you're in that same ballpark, you're good.
That's exactly what I did.
Okay? Then the next one I would do Gennaro's. If he worked 10 problems, how much did he earn?
30.
His 10 goes to 30. 20 goes to 60. 30 is 90. 40 is 120. 50. 150. 60. 180. 70. 210. 80. 240. 90. 270. And 100, 300. I'll zoom out so you can see those. Okay, so that would be the graphs that I would make. Now, here's my question. Are these the only possible points? Could they only have worked 10 or 20 or 30? So there's a lot more points on there. But here's my other question. Is every point between here filled in? Because what does some of these numbers represent? Like if this is 10, right here's 11. What would be between 10 and 11? 10 and a half. Can Jenny work 10 and a half problems?
I mean, kind of.
So are they going to give her half credit and give her $1 instead of $2? No. So what this is leading us into is something we're going to talk about tomorrow, which is, are values discrete or are they continuous? Discrete means you can count all the points. There's only a certain number of points on there. Where continuous means you could draw a line and connect them. And so for these, you couldn't quite draw a line because it's not every single point. It's more points than I have, but it's not all the points.